Our topic for today is Newton law of motion. But before we commence the discussion of today, I would like to beg you all to please subscribe to this YouTube channel, like and share. And if you found it on any other social media page or any other social media platform apart from YouTube, please don't forget to follow, like and share. Our objective for today is to be able to state the three Newton law of motion, and to be able to emphasize the application on our day-to-day activity or our day-to-day life. So we start with Newton's first law of motion. So what does Newton's first law of motion state that? Newton's first law of motion states that a body at rest will remain at rest, and a body in motion will remain in motion at a constant velocity in a straight line, unless acted upon by an external force. So when that comes to your mind, what does it bring? What scenario does it bring to your mindset? That means how can this be applied into our daily life? So let's come back to the discussion. This law essentially states that objects resist change in their motion and requires a force to accelerate or decelerate them. That means they require an external force to push them, or that means to accelerate them or to decelerate them. Newton's second law of motion. What does Newton's second law of motion state that? Newton's second law of motion states that the acceleration of an object or body is directly proportional to the net force acting on it and inversely proportional to its mass. So in mathematical expression, we can express this law as F is equals to ma, where F is the net force applied to an object or to a body, and m is its mass, and a is the acceleration. This law quantifies the relationship between mass, force, and acceleration, showing that a larger force results in a greater acceleration, while a larger mass requires a greater force to achieve the same acceleration. So let's take an example or an illustration. Let's assume the force being applied to two mass of a body is constant, and let's assume the mass of body A is 5 and the mass of body B is 30. You can't compare their acceleration since the force is kept constant. The acceleration at which body A moves, since it's 5, will be greater than the acceleration at which body B moves, because our acceleration is inversely proportional to the mass, and vice versa, assuming all other conditions are kept constant. So Newton's third law of motion. What does Newton's third law of motion state? Newton's third law of motion states that for every action there is an equal and opposite reaction. When one object or body exerts a force on a second object or body, the second object or body exerts an equal and opposite force on the first object. Okay, let's take, for example, let's assume you are sitting on a chair. You are exerting a downward force on the chair, which is called weight. And the chair is exerting an upward force, which is equal to your weight, which is called reaction. So that's what they mean by equal and opposite. The direction is opposite. You are exerting a downward force, while the chair is exerting an upward force. But the magnitude of the two forces are equal. That's what causes a balance when you are seated. So Newton's third law of motion highlights the symmetry of force in interaction between objects and explain some phenomena like friction and the behavior of objects in contact. So I've come to the end of today's class. Please don't forget to subscribe to this YouTube channel, like and share if you get one or two things. And if you found this video on our other social media page or channel, please don't forget to follow the page, like and share. Please, if you have any question, you can reach us by using the comment section on YouTube. While for Facebook, you can message us directly. While on our other social media channels or platform, just put your comment, your question or suggestion or support at the comment section. We'll get to your wish. Please don't forget to subscribe to this YouTube channel. And thanks for watching this video. Bye for now.